Hello everyone. In this video we are going to work out some examples on the intermediate value theorem. So let's begin. So the first example, prove that the equation x cube minus 3x plus 1 is equals to 0 has a root in 0, 1 open interval. So I am assuming a function fx which is x cube minus 3x plus 1, and computing the value of f at 0 I get 1, and the value of f at 1 is nothing but negative 1. So now by the intermediate value theorem I can see that the value at 0 is positive and the value at 1 is negative, and the function is continuous. This function is continuous. So definitely it cuts the x-axis somewhere between 0 and 1, and that is the root of the equation f of x is equals to 0. So let's move on. Prove that there exists a real number x such that x power 1995 plus 1 by 1 plus sine square x is equals to 2011. So now what I am doing is I am transferring all the terms to one side of the equation and assuming a new function fx which is x power 1995 plus 1 by 1 plus sine square x minus 2011. Now check that the value at 0 of the function f is negative, and the value of the function at 2 is big positive value. So again by the intermediate value theorem I can say the value at 0 is negative and the value at 2 is positive, and the function is continuous, so it cuts the x-axis somewhere between 0 and 2, and hence we are done. Let's move on to the next question. This is an interesting problem. It's given that fx be an odd function and continuous in x belongs to R, and f of 1 is given as 1, f of 3 is minus 2, and f of 5 is 3. We need to find the minimum number of roots of fx is equals to 0. Now since f is an odd function I can say that f of minus 1 is minus 1 and f of minus 3 is 2. Similarly f of minus 5 is minus 3. This is because f is an odd function. Now let us plot the graph of the function. F of 1 is somewhere 1, and f of 3 is somewhere here minus 2, f of 5 is 3. Similarly f of negative 1 is negative 1, f of negative 3 is 2, and f of negative 5 is negative 3. So now let's join the points. So if I join the points, since the graph is continuous, it definitely has to cut the x-axis at many points. So f of negative 1 is negative 1, and then f of 1 is positive 1, and then f of 3 is negative 2, and again f of 5 is positive 3. So the graph is something like this. Now since it's continuous, we can see that it has cut the x-axis at 1, 2, 3, 4 and 5 points. So this equation has at least 5 roots. The equation f of x is equals to 0 has at least 5 roots. It might have more roots, but we can't comment. We can comment that it has at least 5 roots. I hope this is clear. So let's move on to the next one. This is also a very interesting question. It is given the function fx is x minus a whole square into x minus b whole square plus x. We need to prove that this takes the value a plus b by 2 for some x naught belongs to a comma b open. So okay, you might have identified that the function is continuous. Let us compute the value of f at a. It is a, and the value of f at b is b. Now by the intermediate value theorem we know that the function, if it is continuous in the closed interval, then it takes every value between fa and fb. Now since fa is a and since fb is equals to b, it takes every value between a and b, and my value a plus b by 2, this definitely lies between a and b for any a and b. So a plus b by 2 is somewhere here. So it definitely takes the value a plus b by 2 for some x naught belongs to a comma b. I hope this is clear. The interesting thing here is the value a plus b by 2 always lies between a and b no matter what a and b are. not only a plus b by 2, something like, let us say I'm given let us say ma plus nb by m plus n. If m and n are positive, this also lies between a and b, provided m comma n are positive. This is because this is nothing but a ratio of m is to n to the points a and b, so it always lies between a and b. So this might be quite helpful in some problems. I hope this is clear. So now there are a couple of questions so that you can try these questions yourself, and if you get the solution, please post it in the comment section, and I will definitely post the hints of the question in the comment section. And I hope you enjoyed watching this video, and if you did, then like, share and subscribe, and if you have any queries, let me know in the comment section. So in the next video we will be doing it on the Rolle's mean value theorem. Until then, keep learning, enjoying. Thanks for watching.